Okay.
All right.
So
Are we live streaming?
people should be able to see part 4B.
Yeah, we can see it.
All right. So
Okay.
good afternoon. It is 4:30 Eastern time, and welcome to part 2 of LED strings, how they work, how they're made, how they fail, and how to fix them. We want to thank the sponsors of this year's VCS, Buscoyo Studios, the sponsor of this room, which is Wally's Lights. And without further ado, I am going to turn this over to Dr. Wizard. Take it away, sir.
All right. Well, I'm assuming we probably pretty much have the same people that we had in the first half. So just real quick, my name is Wizard. That's actually my name. I go by Dr. Wizard on the Christmas forums and other places. On Facebook, though, you'll find me as Merlin Q. Potter. So anyway, we were talking about strings that are dim. And I didn't catch the name of the guy that did the LED keeper. What was his name? What's your name? You still here?
Yes, my name is Dennis Cherry.
Dennis. Okay. So Dennis and I were talking about strings that are dim, and he actually stated it quite well. You will, as you go up and down the string with the LED keeper, you will see a difference in intensity that will clue you into the bad one. It's not a big difference in intensity, and so you have to really look closely. And a little practice on that, though, and you'll get the hang of it. So just look for one side that is the fairly bright, the brightness you would kind of expect, and then the other half will be noticeably dimmer. And again, you can do the divide and conquer and track it down. And when they're dim like that, it sometimes is the LED, but it's more likely that the socket and the leads in there are rusted. So, which we're coming up to actually. So now you've figured out what your bad LED is. How do you change the thing? We're going to get to that here. So going back to those screw-in bulbs, well, you grab the top of the bulb, you turn it counterclockwise, about 4 or 5 turns, and the bulb will come out. Yay! You grip the top of the new bulb, you put it at the top of the socket, and you turn it counterclockwise while you push in. So I hope everybody here knows how to change light bulbs. The individual bulbs are very difficult, if not impossible to repair. It's usually you can't get the covers off without breaking them. That takes some patience and some finesse. And then even once you get the cover off, usually it's 3 little SMD surface mount diodes soldered to a little tiny board in there. And that takes some skill to change a SMD LED. But the bulb may not be the problem. Another very common problem with these is just the socket is not making a good connection on the wire. These work the same as the Gilbert or Vampire plugs. They have little pins that pierce through the insulation to make the connection. And they can get corroded or loose. And so you can try just kind of wiggling the wire around there in the back of the socket. You can pry the back off, move it 1/4 of an inch and crimp it back on. Or even replace the whole socket. You can buy them individually, or you buy bags of them anyway. You know, with $1 a bulb, you want to check that bulb before you throw it out. Try it on the socket. So we're going to do a little terminology here that I'm using in this presentation. This is not official terminology, but we're going to talk about the LED. When I say LED, I'm talking about the actual LED itself. You'll see me talk a lot of times about the base and the lens. So those are there. And when I use the word bulb in this presentation, what I'm referring to is the assembly of the base, the LED, and the lens. And of course, then we've got the socket. So the first type we're going to talk about changing the bulbs is the 5mm without any kind of lens bulb. These are the cheapest ones. They're pretty plain. So a lot of LED strings now have a locking tab. If it's got that, you flip that up and you pull the bulb out of the socket. They can be a little difficult to get out sometimes. And your LED keeper has a special little attachment just for that. And it works quite well, actually. As an alternative, though, a little pair of diagonal pliers or nippy pliers also works pretty good. Just don't squeeze too hard. So once you get it out, look at the leads. And oftentimes you're going to find they're all rusted out. This is unfortunately a very common problem. Assuming that's not your problem, though, well, you want to verify that the LED is bad. And again, your LED keeper has a special little slot just for it. LEDs, of course, are polarity sensitive, so you got to make sure you put it in the right way. And actually, usually what I do, rather than peering at the thing real close with my bad eyes, I just try it one way and then I flip it around 180 and try it the other way. But if you put it in both ways and it doesn't light up, it's bad. If it doesn't light on the first time, turn it over. You take the bulb and base assembly, you bend the leads down, and you pull the LED out. You can bend the leads down with your fingernail, small screwdriver, whatever. Be careful using your fingernail, as I do, because sometimes it goes up under the fingernail and punctures you. Not very comfortable. So let's talk about waterproofing them, or at least making them a lot more water resistant. The best stuff you can use is a stuff called silicone paste. You can get that on Amazon or any electrical type site. If you got a electrical supply house near you, they're going to have it. You can also get the silicone dielectric grease. Again, Amazon and websites. Home Depot has it on their website. And even good old regular Vaseline works pretty well. And so you just put a little dab of it down in the base part before you put a new LED in, and in the socket. So you push your new LED down into the socket and you bend the leads up. You're going to want a 5mm for these. That's what the originals were. Flangeless is preferable because they will sit all the way down into the socket. Again, the 5mm, the flangeless, they're not always easy to find. Even Mole Smell doesn't have a heck of a lot of those. They got plenty of the 3mm, not the 5. Polarity is very important. They are diodes. They only conduct electricity in one way. In most cases, the socket will have a long side and a short side. And all LEDs always will have a long lead and a short lead. And if your socket is like the one pictured, you're going to put the long lead in with the long side. And then you're going to bend your leads up and trim the excess off with your nippy cutters. Nippy cutters definitely work best for this. And then you're going to put it back in the socket. And now my little picture there, I don't have any grease in the or dielectric in that picture. I should. Again, polarity is important. They all have some way or another to make sure they only fit in one way. A lot of times it's a flat spot on one side. It may also be a groove or a little ridge. And if you have the ones with the locking tabs, well, that's a dead giveaway. So that makes it even easier at a glance. Put it back in, test your set, and you celebrate with an adult beverage. So now we're going to talk about these, and these are the ones that most people really don't understand how you go about fixing these, other than change the whole thing with another bulb from a donor set. I'm gonna show you a better way. Um, they do pretty much the same as the 5mm LEDs without the lens that we just talked about. And the only real difference is you got to get the lens on and off. Um, uh, Usually, I use a pair of nippy cutters for this, or regular, a little bit larger diagonal cutters. Different lens styles are going to require some different techniques. And if you got some old sets you can practice on, that's a good idea. Um, uh, so you're going to undo your locking tab. It's got one. Take the bulb out. And you can see in the picture here, I've taken my nippy cutters and I've got it with the flat side down towards the base and the angled side towards the lens. Just a very light grip because I don't want to crush or cut the lens. You rock it back and forth a little bit, and you can wiggle it out. The thing is, they usually fit in pretty tight. I thought I had that in one of the slides here. They're usually a pretty snug fit. And so you may have to work it back and forth a little bit twisting to get it out. Again, if you got some old ones you can practice on, that's great. Test it with your LED tester. Now, if you are absolutely certain it's bad or you don't want to screw with testing it in the LED keeper, you might find it easier to get the lens off while the base is still in the socket, because that gives you just a little more to get your hands around and hold on to. Once you got the lens off, it's like the ones we talked about earlier. You unbend the leads, you pull the LED out, you put some grease in there, dielectric paste, Vaseline, and then you're going to put in, for any of the lens lights, you're going to put in a 3mm flangeless. And that flangeless, in this case, is definitely very important. If it's got a flange on it, the LED will fit all the way down into the base, but then the lens will not because the flange is in the way. If you don't have any flangeless and you're desperate, the trick is you can super glue the lens onto the LED. Don't try to glue it to the base because the plastic they're made out of, nothing sticks to them. So you put your new LED in. Again, you got to watch your polarity. Usually the long lead through the long hole. You'll see in my pictures here, this particular base doesn't have a long hole. So the way you can tell on this particular one is which side is got the flat spot. And you will actually, as you take the old LED out, you need to pay attention to the orientation in relation to the flat spot. You bend your excess leads up and trim them off, and now you're good to go. In fact, you see here I'm talking about the flat spot. And little photo error here, that actually is not a flangeless LED. That one has a flange, so that's not exactly the best example. And then you put the lens back on and you push it all the way in until it clicks. And then you put the socket back in and you test it and you go have your beer. The T5 and the M5 style, they're basically the same thing, but the trick I was showing you before to get the lens off doesn't work. You're going to want a different style of pliers, something that'll kind of grip around the bulb a little bit. It's a good idea to put a layer or two of electric tape or some other tape on there, and that'll give you a little grip and keep you from scratching the lens. And a twisting and a pulling motion, you can usually get the lens off without too much cussing. If you have the C7 and C9 look-alike bulbs, the cover on those just twists off, and then you're going to pull the LED base out of the socket. And for this, your best bet's probably a pair of needle nose pliers or forceps. Depends on exactly how they've done them. I usually use needle nose on these. Unbend the leads, take the LED out, put some dielectric in there, put your new LED in on these because they've got, you know, a nice wide socket, and because that bulb just screws on, you can really use any shape or style of LED in these, and it doesn't really matter. Watch your polarity, test it, and there you go. So do we have any questions on these? Anybody looking for any tricks for a certain kind they've had trouble with? All right, nobody's piping up, so I guess not. So this is our bonus part. This is kind of fun. We're going to talk about three things here. We're going to talk about making custom link strings. We're going to talk about converting them to full wave. And we're going to talk about retrofitting old incandescent strings. So for these parts, you're going to want some basic electrical skills. You don't have to be an engineer. You should know how to use your multimeter, though. Soldering is required for these, and a knowledge of Ohm's law is definitely helps. So with all three of these things we're about to talk about, we're going to do something where we dial in the current. And, you know, you would think, oh, you just use Ohm's law and you calculate the correct resistor for your voltage and for your number of LEDs. And I kept trying to do that, and it wasn't ever coming out right. And then after doing a little thinking about it and a little reading, I realized it's really way more complicated than that. Your AC voltage is a sine wave. It's going up and down and back and forth. Your LEDs all have certain voltage drops, and they don't really light up until they get close to or at that dropping voltage. And so rather than some horrendous math that's probably still not going to get you the right number, it's easier just to dial it in. So you're going to want a 20 k ohm or higher potentiometer. You want a reasonable size one. Don't get one of the little itty bitty ones, because it's going to have to be able to handle, you know, a certain amount of power, not a lot, but the little tiny ones won't handle it. You're going to turn that all the way up to the maximum. You're going to plug in your LEDs. You're going to turn the potentiometer until you get 10 milliamps through the circuit on your meter. Then you're going to disconnect everything, measure the potentiometer with the ohm meter, and now you know what size resistor you need. So here I've drawn out the circuit for you. Your custom link string is going to go to one lead on the pot. Your ammeter is going to go on the other lead on the pot, and then the other lead back to the plug. So you can see we've got our circuit here. Make sure you turn the potentiometer all the way up to the maximum to get started. And then here's an actual photograph of what we just had a drawing of. I kind of like an analog meter for this, but a digital meter works just fine, really. So safety, this is line voltage. It hurts. It can even be deadly. So please be careful, please. Be careful not to touch anything that's exposed. Make sure anything that's exposed doesn't brush up against anything. And you definitely should be working with a ground fault outlet. That'll give you an extra little layer of protection. And let's not be like Mr. Griswold there. So you've hooked it all up, as I just said. What you're going to do is you're going to slowly turn the potentiometer back down, watch your meter, and when you get to about 10 milliamps, that's about what you want. That's the ideal current. As I said, the maximum is 20 in most cases, but again, we're dealing with that sine wave that goes up and down, and your 120 volt, that's the RMS voltage, or the average more voltage, and the peak voltage is actually about 170. Or those of you in the other parts of the world, double that. So that's why we actually want to keep the current about 10 milliamps. Now, if you take some assorted strings, as I was doing when I worked on this presentation, and measure what they are from the factory when they're stock, you'll get readings all over the place, actually, but generally they're around 10 milliamps. So once you've got it dialed in and you got 10 milliamps showing up on your meter, you disconnect everything, and then you can check the potentiometer with an ohm meter and see what it's set to. Then you're going to find the closest resistor value to that. At least a half a watt. I suggest a watt. They do get pretty hot. And if you want to do all the Ohm's law, you can actually figure out what wattage you really have to have. But a little extra safety margin is always good. So now we've talked about the dialing in trick that we're going to use on all three of these next parts. So we're going to start off with making custom link strings. So look at your donor string, figure out how many sections it has, figure out how many LEDs are in each section, and then, of course, where you need to cut it to get your target number or your target length. And it's fixing to rain here, and I have a metal roof, so if it gets noisy, I apologize. So you clip the string at the spot that you figured where you need to. Strip your wires, and then we're going to do the dial in trick to figure out what resistor we need. And of course, that's going to vary according to the number of LEDs and your voltage in your country. Figure out the resistor you need, put it in, put some heat shrink on the wire, solder it, and put the heat shrink back over and shrink it. And there you go. And you've got a custom link string for whatever you need. You know, you got a coral prop that takes 52 LEDs, you can do that. So converting to full wave. A lot of people like the full wave because there's less flicker and the dimming works a little bit better. But when you convert them from half wave to full wave, you're going to double the amount of power that goes through there because they're getting both pulses from both sides of the sine wave instead of just one. So since they're going to get more power, you're going to need to add in an additional current limiting resistor or replace your existing one with a bigger one. So you got to rectify it. That's what makes them full wave. And you're going to want some 400 volt or higher, 1 amp or higher bridge rectifiers. They're not very expensive. I think I got a bag of 50 of them for like $7 or $8. For the United States, 200 volts is not enough because 120 RMS actually has 170 peaks. So that's not much of a margin of error if you only have 200 volts. And if you're in a higher voltage country, I think they come in 600, 800, 1,000. I actually bought 1,000 volt because they were the same price. Plenty of places you can get them. You're going to want some 1/2 inch heat shrink, green preferably. Then you're going to want some liquid electric tape, Flex Seal, or Plastidip. They're all more or less the same thing, actually. And I didn't have it on here, but you're going to want some silicone glue or caulk. And of course, you're going to have to come up with the correct resistor once you've dialed in the current. If you're just looking to get an assortment of resistors, though, they usually end up in the range somewhere between 1K and 6K. If you daisy chain your strings, you have multiple strings put together, the male from one plug into the female the other. All the additional strings that are daisy chained down the line also end up becoming full wave. So you only have to put a rectifier in the first string. But all those daisy chain strings are going to get those extra pulses, more power. So you are going to have to add additional current limiting resistors to them. So here's how you splice it in. You take your rectifier and you bend two of the leads around. It can be the two AC leads or the plus and minus lead, whichever floats your boat. You can see in the picture how I've done that. You can connect the plug up to the two with the little sine wave symbol. Also looks like a, what do they call that thing? Umlaut? No, that's not an umlaut. Well, anyway, it's a little sine wave symbol. And then your LEDs are going to go to the plus and the minus on the bridge rectifier. And it was on the slide, but I don't think I said it. When you're examining your string, getting ready for this, you want to pay attention to on the sockets, which is the positive and which is the negative, so that you hook that up correctly to the rectifier. Polarity counts. Coat everything with your liquid electric tape or whatever, because when you shrink the heat shrink around it, it's not going to shrink all the way. It's not going to get a perfect watertight seal. So give everything 2 to 3 coats of liquid electric tape or plastic, and give it time to dry. Then you can slide your heat shrink over, squirt a little bit of silicone in each end. And then while the silicone is still wet and soft, you shrink down the heat shrink. And it didn't show up in the photographs, but depending on how much silicone you put in there, usually your excess will come squirting out the end when you shrink it down. And you can see the guy shrunk his t-shirt. So now you've got the rectifier in place. The next step is our current limiting resistors, which I said we have to add one. Oh, someone said it's a TILD. That's right. I couldn't remember the name of it. So you pick a good spot to splice it in between any two LEDs, wherever it's convenient. And I put it on the slide. I said this is an addition to the existing resistor, and don't remove the existing one. You can if you want, and just put in a new, bigger one. Because you're still gonna have to dial it in. So if you have multiple sections, clip one of the wires in each section, because you don't want to fry the sections besides the one you're actually testing. Don't strip those wires yet. On the other sections, you're going to strip them on one of the sections, and leave the others unstripped. Connect your potentiometer and your ammeter, and we're going to do that dial in the current trick to find out what size resistor we need. Now, if you've got most springs, they're all going to be the same number per section, 25 or 33 or whatever. And in fact, if you have a bunch of strings you're going to do, you're only going to have to do the dial in trick once. Now, if you change colors or manufacturers, or it's a different size string with different size sections, well, then you're going to need to redo it for each different situation. But if you're doing a bunch of them, it's all the same. You only have to do the dial-in trick once. So once you know the resistor value you want, put on the heat shrink, solder the resistor in. And here's another mistake in the pictures. Besides the value is wrong, stripes, color stripes, that's actually also only a 1/4 watt. Because again, when I was getting ready to take pictures and I'm running around like a maniac, getting everything together, I couldn't find the ones I really wanted to use for the photos. So put your heat shrink on, test it. In this case, you might want to do a little burn-in session, maybe 10, 12, 24 hours, whatever. Help ensure that you actually did get that resistor correct and that they're not all going to fail once you get them out there on your prop. And have a drink if you want. And then finally, retrofitting incandescent strings. A lot of times you have some cool old retro prop that you got somewhere, yard sale, and it's old and it uses the old incandescent mini lights, and you want to convert it to LED. But it's an unusual string. It's got weird spacing. or something like that. So it's not like you can just put an LED string on it. So we're going to tell you how you convert them. You're going to divide your string into sections of no more than 35. You're going to go ahead and take all the sockets out, the bulbs, take the bulbs out of the sockets. Waterproof, put your dielectric in all the bases and all the sockets. Put an LED into each socket and or each base and bend the leads over. So again, like we were talking about the 5 millimeters an hour ago, the 5 millimeter flangeless is the best if you can get them in the style color you want, because they will fit down into the base. If you can't get the flangeless, the ones with a flange will work. And you can use 3 millimeter in there too. They work just fine. As you're putting them in, pay attention to that long lead and mark one side of the socket. So once you've got everything back in, we're going to go through the dial in the current trick for your number of LEDs and figure out what size resistor you need. And then we're going to put the resistor in. And that's the wrong picture. That picture is of the rectifier under the heat shrink. Whoops. And if you're not thirsty by now, I sure am. If you really want or need that mini light look, you can get it at the expense of a real LED string that you sacrifice for the lenses. And what you do is you will just super glue the lenses onto the LEDs before you put them into the bases. I did once many years ago find someone that was selling the mini light style covers just by themselves as replacements. Unfortunately, I've never been able to find them again. So if someone knows where to get those, please let me know. And so, yeah, you're probably going to have to sacrifice a regular string to get the covers, but you probably, hopefully, have an old one in your junk box you can steal the lenses off of. And do we have any questions on these, especially the dialing in trick, because that's important. Really? I figure for sure I have questions on this part. All right, well, I guess I'm going to finish up early here then. Congratulations, everybody. You are now all certified experts on light emitting diodes from Dr. Wizard's School of Technology. I would like to thank all the...
That's awesome.
If somebody wants a certificate, I'll make them. I want to thank all the vendors and sponsors that made the virtual Christmas Summit possible. Oh, we have a question. Okay.
All right. Thank you, Doctor.
Well, we got a question here.
Wait, there's a question.
It's still early here.
Sure.
All right. So somebody says, why operate them on line voltage? Why not operate them on 24 volts? That actually is very doable. I have some that I run on 12 volts just because I happen to have some low voltage controllers with extra channels. So with 24 volts, you're probably going to want to put no more than 6 or 7 in series. And for DC, you can go ahead and use Ohm's law to calculate the dropping resistor you want for that. Someone says he recycles old wall warts, like from old laptops. Yeah, well, those tend to be 19 volts, but you could use any DC voltage you want. You just need to keep the total dropping voltage a little bit below what your supply voltage is. And then you're going to need to calculate with Ohm's law the dropping resistor. And we didn't really talk about DC and Ohm's law on this, so let me run you through that. Basically, you're going to add up all the dropping voltages, 2.1 if they're red, 3.1 if they're green or blue, but you can even mix and match and just add them up accordingly. So say you came up with your total dropping voltage is 20 volts. That's 4 left over. So then you're going to take the 4 volts. You're going to divide that by 0.01, which is the 10 milliamps. And actually, since it's DC, you could probably get away with 15 milliamps easy. So you take the leftover 4 volts and divide by 0.015. And that'll tell you the resistor you would want, which is probably going to be a couple hundred ohms. So yes, you can run them off. You can run them off low voltage DC, and it's actually simpler to figure out the resistor. Do you need to calculate if you are using a potentiometer? No. The whole idea of the potentiometer is to not have to calculate it for the AC line voltage, which, as I said, because it's a sine wave and dropping, and it's weird and hard to calculate it for an AC light string. And so that's why we use the potentiometer. It's just faster and easier. For a DC string, you could use a potentiometer, but you'd want a lower resistance one, because on a DC string on low voltage, your resistor is probably going to only end up being maybe a couple hundred ohms or so. And with DC, it's a pretty straightforward calculations with Ohm's law. And someone put AC voltage varies with the cities. Yes, within a country, though, it usually doesn't vary that much. And even it's going to vary from time of day, depending on the load and things. They don't keep it quite as stable as in theory they should. So you've got a certain tolerance, a certain level of variation that you got to figure in there anyway. You're not going to get it at exactly a certain voltage and exactly 10 milliamps. Of course, now in different countries, if you're in a 240 or 220 volt country, calculate accordingly or adjust accordingly.
All right, what else? Let's think of something else.
Well, I definitely want to thank all the people that put the summit together. I'm not even sure who all is on the committee.
There's quite a few people, and
yeah, I know there is. And I don't know everybody's name that's on the committee.
I got a question.
Yes.
If I bought LED light strings that don't seem to dim very well, some of the new ones I've been picking up at the store, I've started actually going to the dimmer aisle and bringing one over to the light aisle before I buy the LEDs. If they don't seem to dim very well, what can I do about it to make them dimmable, or do I just have to buy a different light string?
Well, the converting to full wave trick will definitely make an improvement. I have also seen some, I've only seen this a couple times, but some of the strings, in addition to the dropping resistor, they've added a capacitor. And that capacitor is why you're not getting the good dimming. And you can take the capacitor out, but then you have to adjust or change the value of the resistor. I've also seen some of these DIY how-tos on the web when they're talking about making your own strings or making custom length strings or whatever. And I've seen the authors of many of these articles tell you to put in a capacitor. And
back in the day, we used to just put a snubber on there, or the joke was use an air freshener. But
yes,
yes, but it worked. It acted as that resistor, and it actually worked.
Yes, exactly. It's a when you take a capacitor and you put it on a alternating current, it has an impedance, and so that impedance basically equates out to a resistance and limits the current going through the resistors. I don't really know any real reason to use a capacitor instead of a resistor, though, other than maybe it keeps the intensity a little more uniform with less flickering. But of course, that's going to affect your dimming. And I've only seen that on a couple strings. I've really seen it more in people's articles than on actual strings. So yeah, if they don't dim well, that is fixable. I'm not sure if you want to go through that much effort. Not that it's that hard, but you can. Now, a lot of people, as I said, like the full wave anyway for the better dimming. So you can always do that.
All right. Well, thank you, Doctor. Thank you, everybody. And we're going to cut off the recording now. Find